Hello learners! Welcome back to General Mathematics Learn by Video series. This is brought to you by QuexBook Smart Mobile Learning and PerkDC Learn Hub. I am Engineer Rex Jason Agustin, and this is our third lecture video on simple and compound interest. This is just a continuation of our discussion on simple and compound interest. We're done with the whole part 1, functions and their graphs. We are now on part 2, basic business mathematics. For this session, our targeted most essential learning competency identified by DepEd, we have computes interest, maturity value, and present value in simple interest environment. The topic outline would be ordinary simple interest, exact simple interest, then computation of unknown rate, maturity value, and principal. In line with the MELC, our learning objectives are to distinguish between ordinary and exact simple interest, and to compute for interest, maturity value or future value, and present value in simple interest environment. From our previous lecture videos, we already know that there are two types of interest. We have simple interest and compound interest. Simple interest is the interest that is computed based on the principal only. And compound interest is the interest that is computed based on the principal and also on the accumulated past interest. In this lecture video, we are going to focus on the two types of simple interest. We have ordinary simple interest and exact simple interest. Ordinary simple interest. Ordinary simple interest is based on one banker's year. We use the formulas I is equal to PIN, F is equal to P plus I, F is equal to P times quantity 1 plus I times N, where uppercase I is the interest earned, F is the future value or maturity value, P is the principal or present value, lowercase I is equal to R over 360, that is our rate of interest per day, where R is the interest rate in 1 year or what we call nominal rate, and N is the total number of interest periods in days. Okay? Now, what is a banker's year? One banker's year is equal to 360 days. Okay? That comes from the assumption that in a year, we have 12 months and each month has 30 days. So 12 times 30, that is equal to 360 days. That is what we call banker's year. Okay? Example number 1. Determine the ordinary simple interest for 50,000 pesos for 9 months and 10 days if the annual interest is 10%. Our given are the principal P or the present value, which is 50,000 pesos, the nominal rate R or the stated yearly interest rate 10% or 0.10, our interest rate per day, that's R over 360, rate of interest per day for ordinary simple interest computation, and N is equal to 9 months and 10 days. We are required to solve for the uppercase I or the interest earned. Our solution would be, first, we need to convert 9 months and 10 days into days. That would be 9 months times 30 days per month. Okay, we can cancel the unit month plus 10 days. That would be 280 days. Okay, next, we use the formula I is equal to PIN. Okay, let's just substitute the given. I is equal to 50,000 pesos times 0.10 divided by 360 days times 280 days. So we can see that the unit days can be cancelled, and that will give us an answer of 3,888.89 pesos. Our answer for example number 1 is 3,888.89 pesos. Okay? Next, example number 2. How much interest is charged when 20,000 pesos is borrowed for 7 months at an annual interest rate of 5%? We have the following given. Principal or present value P is equal to 20,000 pesos. Nominal rate R or the yearly interest stated in the problem, 5% or 0.05. Interest per period, we can use lowercase I is equal to R over 12. That is our rate of interest per month. We have here over 12 because we have 12 months in 1 year. And N is equal to 7 months. We are required to solve for the uppercase I or the interest earned. And our solution would be interest earned I is equal to P times I times N. Just substitute the given. We will have interest earned is equal to 20,000 pesos times 0.05 divided by 12 months times 7 months. We can cancel the unit months and we will have the answer 583.33 pesos. Okay? Now, if you are not comfortable using the interest per period I equals R over 12, simply because this is not what is shown in the previous slide, we can also use the interest per period I is equal to R over 360. That is our rate of interest per day. In one banker's year, we have 360 days, right? If we are going to use this one, our solution would be like this. I is equal to P times I times N. Interest earned is equal to 20,000 pesos times 0.05 divided by 360 days times 7 months times 30 days per month. Okay, we just need to convert 7 months into days. We can cancel the unit months and we can also cancel the unit days. And we will still get the same answer. Interest earned is equal to 583.33 pesos. Alright? Let us now have exact simple interest. Exact simple interest is based on the exact number of days in a given year in our Gregorian calendar, which is 365 for a normal year and 366 days for leap year. For exact simple interest, we use the following formulas. I is equal to P times I times N, F is equal to P plus I, and F is equal to P times quantity 1 plus I times N. These are the same formulas that we have for ordinary simple interest, except that our basis for a year would be the actual number of days in a year, which can be 365 days or 360 days instead of 360 days for banker's year. Okay? Where uppercase I is equal to interest earned, uppercase F is the future value or maturity value, P is the principal or present value, lowercase I, that is R over 365. This is our rate of interest per day for a normal year. And I is equal to R over 366 days. this is our rate of interest per day for leap year. R is equal to interest rate in 1 year, or what we call nominal rate of interest, and N is the total number of interest periods in days. How do we determine whether the year is a leap year or not? If the year is divisible by 4, the year is said to be a leap year with 366 days. Otherwise, it is just a normal year with 365 days. However, for centennial years, years ending with two zeros, like year 1800, year 1900, year 2000, and so on, it must be divisible by 400 for it to be considered leap year. Let's have here some examples. Year 1996, 1997, year 2020, and year 2021. Since 1996 is divisible by 4, it is a leap year. 1997 is not divisible by 4, therefore it is not a leap year. Year 2020 is divisible by 4, so it is a leap year. And year 2021 is not divisible by 4, so it is not a leap year. Let's have some more. Year 1600, year 1700, year 1800, and year 2000. Year 1600 is divisible by 400, so it is a leap year. Okay? Year 1700 is not a leap year. Though year 1700 is divisible by 4, it is not divisible by 400. Okay? It is not a leap year. Year 1800 is not a leap year too. Year 1800 is divisible by 4, but it is not divisible by 400. Remember that for centennial years, they have to be divisible by 400 for it to be considered leap year. Okay? Year 2000 is divisible by 400, so it is a leap year. Alright? Now, how can we remember the number of days in each month? Because it is quite confusing for some to remember which month has 31 days and which month has 30 days, right? Here is a technique that we can use for us to easily remember the number of days in each month. Close your fists and take a look at your knuckles. Assign each month chronologically to your knuckles and in the depressions between your knuckles. Like this one. We have here January, February, March, April, May, June, July, then August, September, October, November, and December. Okay? So those months that lands on your knuckles are the months with 31 days. Count knuckles as 31 days. January, March, May, July, August, October, December. Those are the months with 31 days. Okay? And those months that lands on the depression between your knuckles, February, April, June, September, November, they have 30 days or 28 or 29 in the case of February. Count depressions between knuckles as 30 or 28 or 29 days. February has 28 days during a normal year or 29 days during a leap year. April, June, September, and November have 30 days each. Okay? That's it. Let us have example number 3. Determine the exact simple interest for 10,000 pesos from January 15 to June 20, 2016 if the rate of simple interest is 4%. We have the following given: principal or present value 10,000 pesos, nominal rate or the stated yearly interest rate 4% or 0.04, interest per period, we're going to use R over 366. That is our rate of interest per day. And N is from January 15 to June 20, 2016. We are required to solve for the uppercase I, or the interest earned. And for our solution, we should note first that year 2016 is a leap year. Year 2016 is divisible by 4, therefore, it is a leap year. That's why we have here 366, because in a leap year, we have 366 days. Alright? Then count the actual number of days for the interest period. Okay, let's count how many days is January 15 to June 20, 2016. Okay, for January, that's 16 days. Okay, from January 15 to January 31, so that's 16 days. For the whole month of February, that is 29 days. Since it is a leap year, February has 29 days. For the whole month of March, that is 31 days. For the whole month of April, that is 30 days. For the whole month of May, we have 31 days. And for June, 20 days. Because we have here until June 20 only. So for June, we note 20 days, right? Then add to get the total number of days, 157 days. Okay? Then we use the formula interest is equal to P times I times N. Okay? Just substitute the given. Interest earned I is equal to 10,000 pesos times 0.04 divided by 366 days times 157 days. We can cancel the unit days and we will get the answer 171.58 pesos. That is the interest earned. Okay? For example number 3, the answer is 171.58. Example number 4. Determine the exact simple interest for 3,000 pesos from January 10 to May 10, 2019 at 8% interest. We have the following given. Principal or present value 3,000 pesos. Nominal rate or the stated yearly interest rate 8% or 0.08. I is equal to R over 365. This is our rate of interest per day. And N is from January 10 to May 10, 2019. Okay? We are required again to solve for the uppercase I, or the interest earned. But for our solution, we should note first that year 2019 is not a leap year. Okay? Year 2019 is not divisible by 4, therefore it is not a leap year. That's why we have here 365. I is equal to R over 365 because in a normal year, we only have 365 days. Okay? Then, count the actual number of days for the interest period. Okay, we need to know how many days is it from January 10 to May 10, 2019. For the month of January, we're going to note 21 days. That is from January 10 to January 31, right? That's 21 days. For the whole month of February, that's 28 days. Since 2019 is not a leap year, month of February only has 28 days. The whole month of March has 31 days. The whole month of April, 30 days. The whole month of May, it's only until May 10, right? So for May, we're going to note 10 days. Okay? Then just add to get the total number of days, 120 days. Okay? Then we use the formula interest earned I is equal to P times I times N. Just substitute the given. Interest earned I is equal to 3,000 pesos times 0.08 divided by 365 days times 120 days. We can cancel the unit days. And our answer would be 78.90 pesos. Alright? For example number 4, the interest earned is 78.90 pesos. In the next examples, we're going to have computation of unknown rate, maturity value, and principal in simple interest environment. Example number 5. If an entrepreneur applies for a loan amounting to 50,000 pesos in a bank, the simple interest of which is 15,750 pesos for 3 years, what interest rate is being charged? We are given the following: principal or present value 50,000 pesos, interest earned 15,750 pesos, and period N is equal to 3 years. We are required to solve for the interest rate I. Solution. From the formula interest earned I is equal to principal P times interest rate I times period N, we can say that interest rate I is equal to interest earned over principal P times period N. We just substitute the following given, and we will have 15,750 pesos over 50,000 pesos times 3 years. We can cancel the unit pesos, and our answer would be I is equal to 0.105, or that is 10.5% per year. Okay? For example number 5, our answer is 10.5% per year. Example number 6. Find the maturity value if 1 million pesos is invested at an annual simple interest rate 2% after 5 years. For example number 6, our given are principal P, 1 million pesos, interest rate I, 2% or 0.02 per year, and N is equal to 5 years. We are required for the unknown future value or maturity value F. For our solution number 1, we can compute for the interest earned of the investment. I is equal to P times I times N. Okay, substitute the given. Interest earned is equal to 1 million pesos times 0.02 times 5. The investment will earn 100,000 pesos after 5 years. And to compute for the future value, we know that future value is equal to the principal or present value plus the earned interest. And that is 1 million pesos plus 100,000. The maturity value or future value is 1,100,000 pesos. Okay? That's just one way to solve example number 6. We can also use direct substitution to our formula. So we have here solution number 2. We can directly substitute the given to the formula future value F is equal to principal P times quantity 1 plus I times N. Okay? It would be like this. Future value is equal to 1 million pesos times quantity 1 plus 0.02 times 5. We will still get the same answer. Maturity value or future value is equal to 1.1 million pesos. Okay. Next, example number 7. How much should you invest at 8% annual simple interest in order to have 300,000 pesos in 2 years? The given are future value or maturity value F, 300,000 pesos, interest rate I is equal to 0.08 or 8% per year, and period N is equal to 2 years. We are required to solve for the unknown principal or present value of the investment. Solution. From the formula, future value F is equal to principal P times quantity 1 plus I times N. We just need to manipulate this equation to have principal P is equal to future value over 1 plus I times N. Just substitute the given. Principal P is equal to 300,000 pesos over 1 plus 0.08 times 2. Our answer would be 258,620.69 pesos. Okay? Okay, that's it. Now let's check what have we learned. In this session, we were able to distinguish between ordinary and exact simple interest. And we were also able to compute for interest, maturity value, or future value and present value in simple interest environment. Alright, in our next video, we're going to have simple and compound interest part 4. For more related practice problems in this topic, you may use our QuexBook General Mathematics app available from Google Play Store and answer Chapter 4. Thank you and God bless!